Hello everyone, in this video I'm going to show you my latest addition to the shop. This is my Avid CNC Pro Series 48x48 CNC router. In this video I just kind of want to cover a broad overview of this machine, how I ended up getting it, putting it together, what this thing even is, what can it do, and what I plan on doing with it. So let's just kind of dive right in and see what the heck this thing really even is. So what is a CNC router? A CNC router is not all that different from a CNC milling machine or just, a CNC machine in general. Traditionally, the difference between a router and a milling machine is that the router is made for more routing applications, which is basically like 2D, slots, channels, cutting out panels, things like that. A machine like this would be used for, let's say, a cabinet shop or a panel shop, making cabinets and panels and furniture and things like that. It is traditionally used for wood, although this can be used for aluminum, and towards the end of this video, I will show you this cutting some aluminum, and my goal for this machine is going to be primarily for aluminum, soft metals, and occasionally wood and plastic. But just really generally speaking, I don't want to get into the full difference between a CNC router and a CNC milling machine, but this is going to 100% supplement my Tormach. My Tormach is still going to be used for most of my heavy-duty machining things, like you saw a few weeks back I did the machining of the S7 weapon. I'm still going to be using the Tormach for that, but this is going to be used for possibly making jigs, since if I'm doing something in the Tormach, I might want to make something larger and make a jig, and then that eventually goes inside the machine. So making jigs, things like that, plastics, woods, and aluminum is what I plan on using this for. So why end up with a CNC router instead of just upgrading the Tormach to something larger? Well, it really comes down to travel. The travels on this are just absolutely absurd compared to what I can get in a similar footprint for a CNC milling machine. For instance, my Tormach right now has, I think it's 6 inches of Y travel. So, if you're looking at the machine going back and forth like that, that's the Y travel. It has about 6 inches of travel there and about 10 inches of travel on the X axis and somewhere around like 10 to 12 inches on the Z. This has about 12 inches of travel on the Z, although you only have about 8 inches from here to the bottom of the gantry, so you really only have about 8 inches of working room. But in terms of the X and the Y, I'm at 49 inches and 49 inches. So to give you an idea, the maximum work envelope of the Tormach is literally about this big, just maybe 2 hands worth, something like that. So, in terms of parts that the Tormach can do, the largest piece that it can do, I can probably do 20 of them at a time on this. So that allows me to make much larger pieces. And because this can do aluminum, I'm kind of open to doing a lot more interesting stuff as long as I stick with aluminum, and it can do some light steel work. But generally that's the big difference between a CNC router and a milling machine. A CNC router is going to have a much larger capacity but a lot less rigidity, and then obviously the opposite is true. A CNC milling machine is going to have much higher rigidity but at the sacrifice of a lot less work envelope. If you clicked on this video because you're interested in CNC routers or looking to purchase your own, or maybe saw that this was an Avid CNC and you're wanting some impressions and things like that, I want to talk just a little bit about how I ended up with an Avid CNC, which is formerly CNC Router Parts brand router. There's a lot of stuff out there and there's quite a huge range in terms of price. And for the sake of transparency, I'm just going to kind of throw everything out here. And I do want to say before I get too far deep into this video, this was purchased with my own money. This is not a sponsorship type of thing. This video is not sponsored by Avid. I have really no connection with them whatsoever. I mean, we've been chatting and stuff, but I did pay for this 100% retail with my own money. So I just want to be kind of clear about that since I have other kind of sponsor stuff in my videos. But I ended up with the Avid CNC for a few different reasons. I'm kind of going to do a walk around and just kind of show you some features of this later, and some of those things will become apparent. But you can basically get a CNC router for, I don't know, $500 if you go on eBay and look for like the 3040s and the 6090 CNCs, which are these little like kind of tabletop CNC machines. You can definitely get anything from that. And then it goes all the way up to the commercial units, which for a 4x4 or a 4x8, it can be, you know, like $30,000 to $50,000. So there's a big range between $500, you know, for the 3040 or the 6090 Chinese CNC things, and even like a Shapeoko at about, I think, $1,500. The X-Carve is somewhere around that range. And then you go all the way up to the commercial ones at the tens of thousands, somewhere between, let's just call it $20,000 and $50,000 for there. This sits pretty firmly in the middle, all in as you see it with the little control thing I have over here that I'm going to show in a later video, but everything needed to run this is about 11 grand. I have about $11,000 total into this, and that's pretty much everything you need to get it running. Now this does come as a kit, so you do need to assemble it, so it's a little bit different than some of the Chinese machines out there. If you go to AliExpress or Alibaba, or even I think on eBay and Automation Direct, I'm just throwing out a bunch of websites for you. If you go on any of those sites, you can find 4x4, 4x8 CNC machines. They're just kind of a welded frame, welded structure thing. You can do those for anywhere from like $6,000 to $15,000. And I did look at those, but I did want to go with kind of a more established company, someone that had some support behind it. And I did kind of like the fit, the finish, and a lot of the little things that they've thought about with this. So that's kind of why I ended up with the Avid. I've been looking at them for a while. It's kind of a mature company, and they have a nice ecosystem of things that all play together. And really, I wanted to get up and running quickly with the machine, so I felt like this would be my best bet for that. So this does come as a kit. You basically get this in 2 different shipments. You get the actual 80/20 extrusions kind of in one shipment from 80/20 directly. And you know, for anyone not familiar, 80/20 is just simply a structural aluminum extrusion, which is the base of the majority of this machine. And then Avid CNC actually does all of the other things, like all these little connectors here at the end, the dust guards, the linear bearings, this whole Z setup, the arms at the side. They kind of do all those pieces separately, and then they have these kind of step-by-step instructions that they walk you through. And the reason I'm not doing a full build walkthrough is because they have it, and they also have a really good step through on their website. So if you go to their website, they have a complete step-by-step, and that's exactly what I followed to build it. So I'm not going to be adding anything showing you the full assembly of this. I will probably inject some video, you know, time lapse of me building this thing somewhere in this video, because it just kind of cuts up just sitting there staring at me. But this video is not meant to serve as an assembly guide, because quite frankly, they have that covered, and covered quite well. I was pretty impressed with the assembly instructions. I never really felt lost. I mean, not that that's really a big deal. I've, you know, done this kind of thing before, but it was pretty easy to do. All told, it was about 3 days. I started it on a previous weekend, and I spent pretty much all day Saturday and Sunday putting it together, and then the following weekend I just needed 1 day to kind of finish up all the wiring, put the spoil board on. So, you know, for someone like me that's a little bit more experienced, it was 3 days, start to finish, and I had it cutting parts, and I'm pretty much done with it. If you're less experienced, call it like 4 to 6 days. And if you're doing it like during, you know, business hours, if you're a business looking to do one of these, you could probably bang it out in 2 days if you had a couple people. So that just kind of gives you an idea of the assembly. Next step, let's just kind of walk around, and I'll show you a couple features that kind of made me want to buy it, and you know, how I ultimately ended up at this decision, and just kind of give you an idea of what the machine's like. So let's first take a look at the gantry. The gantry was one of the main reasons why I went with this model. In person, you know, the camera just really doesn't get the sense of scale of this thing, but it is really massive and really beefy, and it has this huge extrusion running the length of it. And one of the things I liked about this machine is it actually uses linear bearings. A lot of the more inexpensive machines will just run little rollers along the outside of this extrusion. You know, you've seen that with like little skate bearings or little V-groove bearings. I think 80/20 even makes their own kind of version that rides on the outside of their extrusion. But this has these nice linear tracks and these linear bearings over here, and I really like that concept. This also doesn't use ball screws or any kind of lead screw on the Y or the X axis, and the reason that it does that is because when you start to get this long, it's really hard to keep those straight. So this actually uses a gear track, and over here we have the head. I'll get a better look at this later, but you have basically a timing pulley, and then you have a pinion that is spring-loaded that rides along this gear track. But I was really impressed with just the size and the weight and the heft of this gantry, because for milling materials like aluminum, this is going to be the most important thing. This is where your loss of rigidity is going to come from, is right here. So I was pretty impressed with how the gantry was made. Here's a better look at the Z-axis. I ended up going with the extended Z-axis, which gives me, it's about 14 inches total worth of travel. And I'm not really sure at this point if that was the right idea. It really wasn't that much more. I think it was only a couple $100 extra, but it does give me this extra travel. If I ever want to run off the end of the bed, I'll talk about that later. But it is a nice, pretty beefy little assembly here. This is another one of those points where you're going to lose some rigidity just because of the nature of it. This is very different than something like a vertical CNC where you just have this huge column that is fixed. You obviously have this piece that is going up and down. Let's move this down just a little bit. Everything on here is a Nema 34 motor, so it's got plenty of speed and plenty of power for whatever I'm doing. The spindle that is sitting on here right now is a 2.2 kilowatt, so about a 3 horsepower. So just in comparison, the spindle that I have on my Tormach 440 is only about a 1 horsepower or 750 watt. So this is about 3 times more powerful than what the Tormach has, but it is very different. This is an ER20 collet, which means that it just has a collet down here for holding end mills. So really tool changes are a bit more of a pain. You basically have to touch off every single bit every time you change, and the speed is a lot faster. This goes from like about 8,000 RPM, I think up to about 26,000 RPM. So if you want to do steel or anything that requires a much lower RPM, you're kind of out of luck with this. Here's a better look at the Y-axis assembly, I guess, and this is mirrored up on top of the gantry as well. It's basically the same setup. You've got this large Nema 34, I think something like 1,000 ounce inch, something like that. You have a nice little tensioner here that drags it up into the gear rack, and then you have a timing pulley, and then there's a pinion inside of here that basically it pulls it up into this gear rack, and that is what gives you the motion. And this thing can move pretty quick. I'll show that a little bit later. I also have these nice proximity sensors. These are actually metal, so when metal comes into contact with them, they're not metal, but they sense when metal comes into contact with them. And these are nice and accurate. And the nice thing is, for a CNC machine like this, where everything's kind of open, you don't really necessarily want a micro switch that you can bump into. But yeah, this kind of gives you an idea what the edge looks like. And I do like that there's a lot of wire maintenance and wire track everywhere. So there are a lot of wires on this thing. One of the things that I liked about Avid, and one of the reasons why I went with them, is they take care of a lot of the shortcuts. If I was going to build a machine from scratch, I would have done that, but I've kind of been there, done that before, and I just kind of wanted to get a machine and go really quickly. So this is the main controller, and it basically comes shipped like this, plug and play, ready to go. And they did a really nice job of laying everything out. and choosing the right hardware. You know, I've got two nice big power supplies. You've got a couple smaller power supplies for the logic stuff up here. You have a smooth stepper board that goes to kind of a custom distribution PCB behind it. And then you've got your 4 stepper drivers. You've got a nice fan. You have all your connections down here already pre-terminated. And then even a couple solid state relays so that you can control some other stuff on the outside. So I like that this is already put together, already wired up. This is the kind of stuff that takes forever to do. So I like that it's already done for me. Thank you, Andrew, for making this. I think in the end, the decision came down to either buying my own router like this or building one. And for me to sit down, design, and build a router, it probably would have come out very similar to this after several iterations. This is about what I would have ended up making. And so really just spending the extra money on the kit allowed me that ability to save, you know, 6 months or a year's worth of my time and frustration. And of course, all the extra money that you kind of pour into something when you learn, oh, I bought the wrong part. I should have bought this instead. I kind of priced it out. When I really priced out the 80/20, the electronics and everything else, this wasn't significantly more than just building my own kit, assuming that I didn't make any mistakes. So there's a couple fun things that I like about this versus something like a welded steel frame. Although a welded steel frame could be a little bit more rigid, I like the ability that I can kind of reconfigure this 80/20 round. One of the things that I want to possibly do is at one of the lengths of travel, the ends of travel of the gantry, is I want to do a vertical table. So I could simply take these pieces of 80/20, slide them in a little bit, have the gantry move past that, and then do a vertical table so that this head can come down and I can actually machine the ends of things. So if you're doing you know, a robot like crippling depression or something like that, you have these nice long panels and I need to drill and tap into the ends of them. So being able to stand it vertically on a vertical table and drill into the end of it, that would be very nice. They also have a 4th axis that I can eventually put on here and do now 4th axis stuff. They also have an extension to where I can extend this out to an 8-foot, things like that. So I really kind of like the flexibility and the modularness of some of this. So that's kind of what led me to go with this, as well as the ecosystem. You know, I've got a nice little e-stop button here. I've got the little touch plate that's all integrated. You have the limit switches and everything. It's just a nice little package and everything comes together. So I'm pretty happy with that so far. So I think the last thing that I'd like to show is just kind of it moving around a little bit. Now, I do have the upgraded Nema 34 motor, so it moves a little bit quicker than I guess the stock one. And so this can peak out, I think, around 600 inches per minute, which is very necessary considering the size of it. So let me just move from kind of 0, to the far limits of the travel. So it really doesn't take it long to go from one end to the other, and that's 44, 45 inches, so it can move pretty quickly, and most cutting feed rates I'm finding on this are happy around, I don't know, 100 inches per minute or so. And finally, here's a little short video clip that I made of it machining some aluminum. This is a pretty simple setup here. I'm doing just a 2-flute, 1/4-inch end mill. I'm going all the way down depth of cut. So the depth of cut is a 1/4 inch. Actually, I think it's 0.2 is the full depth of cut. I'm running at about 60 inches per minute, something like that. And I want to say I'm about 50 thou width of cut. And the spindle speed's only about 10,000 RPM. Now, the finish is okay on this. I definitely need to do a different clamping method. This is just being taped down, but I could definitely go a lot faster. I unfortunately didn't record any audio here, but there was a little bit of squealing because it is rubbing just a tiny bit. The chips look decent, but I definitely should be going probably closer to 150 inches per minute with maybe like 15,000 RPM. I still got to play with this. This was honestly my very first test cut with this machine, period. But so far, so good. I mean, it has no issues whatsoever in aluminum. This is almost the exact same settings that I use on the Tormach for cutting aluminum, and there was no issue whatsoever. This was also completely dry, no air blast, no lubrication, nothing like that. So I have some pretty strong hopes for this. I think if I can do like 150 inch per minute cutting, then I can start doing some really large parts with this. So this was my overview for the Avid CNC Pro Series 48x48 CNC router that I just got. So far, I am actually pretty darn happy with it. The instructions were fantastic. Seriously, I haven't seen better assembly instructions on much. This really was probably one of the best assembly instructions, and just kind of the layout of each step and the way everything was packaged, really top notch. I was really happy about that. Everything went together as expected. You know, there's always a little bit of buyer's remorse when you get something. It's like, oh, that feature isn't exactly what I thought, or this wasn't really as cool as I thought it was going to be. But I think for this, so far, everything's pretty good. I'm really happy with everything so far, and I'm not usually happy. I'm usually nitpicking, you know, something here or there, but so far this is still pretty cool. I think the size of it and the scale of it is maybe helping that a little bit. But generally speaking, it's all good at this point. So I'm definitely gonna get some aluminum on this. You're gonna see this a lot more in my upcoming videos. I also need to do some kind of video for this tool cart thing that I have sitting right here out of frame. This is the full controller that's running the Mach 4. I do actually have the new version of this that has Mach 4 on it, which maybe the time this video comes out, they will have officially released, but I complained enough about Mach 3 that they just upgraded me to the Mach 4 instead, because I hate Mach 3. So anyway, all that being said, thanks for watching. This is going to be showing up quite a bit more. If you have any questions, definitely ask below. But so far, this gives my thumbs up. So thanks for watching. Check out my Facebook page. Check out the links below for all other information, and we'll see you next time.